We're doing page 18 and page 19 today. So what we're going to be doing is we're going to be multiplying, and they say it really nicely here, multiplying using exponents with a common base. Now remember when we have a number, and I want to zoom in here real fast, that this is the base, and this is the exponent. So we're going to be multiplying exponents when they have a common base. So what they're showing you here in this example, if 7 times 7 and 7 times 4 is, or 7, if 7 to the second power is 7 times 7, and 7 to the fourth is 7 times 7 times 7 times 7, then, and be aware, now watch, I want to show you this, at 7 to the 7th power, and look, here it is, because it's pink, and then we're going to highlight this one in green. 1, 2, 3, 4. Watch this. 1, 2, 3, 4. That we write it as a 6. And I want you to, and if I were to write very small under here, how many 7s we have? We have 1. Oh, let me get into the drawing form. We have 1, 2, 3, 4, 5, 6, 7. So really what we are going to be doing is going 7 to the second plus the 4 equals 7 to the 6th. And let me highlight that one more time for you. All we have to do is add the exponents when they have the same base. So they give us another example. So let's try this out. We have 2 times 2 times 2. Awesome. And let's highlight that one so you guys can see it. And these are going to be red or purple. And then we have the same base again, which is 2. We're going to go 4 times. 1, 2, 3, 4. And we'll highlight that one as green. And now watch what we end up having. We end up having 1, 2, 3, which is our original purple. And then we end up having 1, 2, 3, 4. Back at our green. So how can this be written? They want to know. Well, if I have 2 to the third plus the 4th power coming from here and here, and it can be written as 2 to the 7th. So we add. That's really how easy this is that as long as their base is the same, we will be adding. So they say over here, do not evaluate. They just want you to simplify. So notice I have the same base. So that means I add these two numbers. So it's going to be 7 to the third plus the 1 gives me 7 to the 4th. And I forgot to mention we are doing only evens today. So let's try this. I have the same base. So 4 is going to be my base, and then I have 2 plus 7 gives me 9. But they try to confuse us. On number 9, they give us 3. 1, 2, 3. That's okay. We can still do that. 9 times to the first power plus the third power plus the fifth power. So this would give me 4 and then 9. So I have 9 to the 9th power. Whew, you guys got this. You can keep going. They do 9 for us and they say, hey, wait a second. Look at this crazy thing here. We have a base that's, and that wasn't supposed to happen that way. We have a base that's not the same. So we just leave it all on its own. We keep it separate. It'd be like if I was hanging up shirts and pants. We put them on separate hangers. So let me show you how they did this. They took these two. They went 4 to the second plus the third times 3 to the second. And that's how they got 4 to the fifth, 3 to the second. So when we're looking at number 11, 9 is all on its own. We can even put that up here, times 9 squared. We don't even have to mess with it. But I have these two that have the same base. So I'm going to add those together, 5 plus 1. And now I get 2 to the 6. So 2 to the small 6. That's when we're multiplying. Page 19 changes the rules on us a little bit. Now we're going to be, and we're doing evens again. Now we're going to be dividing using exponents. Well, if multiplying is adding, then dividing is going to be subtracting. So here's what they do. They show you, they expand it all out nicely for you on our example. They show us 3 to the 5 over 3 to the third, and they cross them out. So what they're showing you, and it might not be very clear, is that this is 3 over 3 times 3 over 3 times 3 over 3. So if I were to, since 3 over 3 equals 1, you can simplify it by canceling it. So that's how they cancel that out. And then whatever's left is what we put up. So the trick is this is really going to be 3 to the fifth minus 2. Gives me 3 to the second. They give us another example. Over here, they have 4 to the fourth divided by 4 to the third. So I'm going to follow my example of subtracting those exponents because my bases are the same. So 4 to the 4 minus 3, and that gives me 4 to the first power. So we subtract. Allow yourself to take a breath and keep it very simple. Multiplying we add, division we subtract. So let's take a look at this one. So I'm going to go, I have the same base, so I'm putting that down. Now I'm going to go 7 minus 2, and that's going to give me 5. 8, they give us the division problem written out, and that's no different than if it was a fraction, which is fine. So I have the same base, that's important. And then I go 3 minus 2, and that gives me 1. 7, they try to trick you. They're like, hey, wait a second. You have multiplying of the same base and then division. That's okay, guys. Let's write this out. So I know that when I multiply, let's do the first step down here. I'm going to go 3 to the third plus 4. Now I'm going to subtract my 5. All right, 3 plus 4 is 7, so I have 3 to the 7th minus 5. That's simple. That's 3 squared, or 3 to the second power. And let's take a look at number 8. And I know that I want you guys to do evens, but 8 throws us a monkey in the middle. They give us a different base. Notice how 3 is a different base than 4. That means it's left on its own. So let's go and work this out. So I know I'm going to have 3 squared. So we're going to put 3 squared here. But now I have 4 squared to 4 squared. So I have 4 to the second minus 4 to the second. So that 4 to the second divided by 4 to the second gives me 4 to the second minus the second power, which equals 4 to the 0 power. And secret word, that equals 1. So multiply this by 1, and I still just get 3 to the second. So that is all extra. Okay? Be aware of that when you guys are doing numbers 10 and 12. If you get stuck, come find me in office hours. I'm happy to help you.